So my friend, the day has finally come. You have to resolve the famous swap function. This is considered the benchmark for understanding pointers in the C programming language. So we're gonna solve together this famous riddle, all right? It is not complicated at all. If you understand pointers, you can solve by yourself very easily. If you cannot, just watch the video. Maybe I can give you some tips. So, long story short, we have to create a function that swaps the value of two integers whose addresses are entered as parameters. Here's the prototype. We have a void as a return value, and we have two pointers to integer as an input. Let's dive into the code. Here I have three implementations of the swap function. I have my naive one, I have my normal one, and then I have also a pro solution here. Look at that. To really understand this swap program, you need to know how the stack works, how functions in general behave, and the bare minimum of pointers. So if you think that these three elements are kind of tricky for you, I really suggest to you to watch some tutorials. Of course, I will give you some links, the ones I've used to learn this stuff. Okay, let's try to understand ourselves what is going on. Here you have the program in all its glory. We start from the naive implementation of the swap function, so you can really appreciate the concepts that you have to understand thanks to this exercise. We start as usual from the main function. I declare two variables, n and n1. I give these two variables the value 42 and 21. Then I print their values. Then I call my swap naive function, giving, pay attention here, as an argument the two values. I'm not giving the address here. I'm giving to the function the bare bone values. And then I just print again the values. So as usual, I compile my code and then I just run. As you can see here, I have my before and after, which are equal. So no swap here, nothing worked properly. My naive swap function didn't work out. Of course it didn't. And now I will explain you why. As you surely know, all the programs in C start from the typedef function main. This function will call eventually some other functions that will call other function and so forth. So you can think of a program as just a fancy series of functions calling one each other. And at the end of the day, the main function is just a resume. It's just a short form of all your program. If you are a good programmer, you can write programs that are understandable only by reading the main function. So if you give correct and easy to understand intelligible names to your functions, to the variables which are inside the main function, you can really deduce what all the program in general is gonna perform. So at the beginning, we have our delightful main function. As you can see here, I have a little sketch that represents the stack. I want you to think about the stack as a fancy series of boxes, isolated one each other. And inside these boxes, I can insert my functions. A function, of course, is a block itself, so it is an isolated piece of code. So in every box in my stack, I can put my boxes, my functions. As you can see in this case, I have my main function. I've put inside the first place, the first pot of my stack. And inside my main function, I have some variable declarations and some calling functions. As you can see, I have a declaration of an x and y variable. I give the values 42 and 24. And then what do? Well, then I call the function swap, my naive swap function. And I give to this function the values x and y. But pay attention here, this is the key point. I give the values themselves. I am not giving the address. When I pass values in this fashion, we say in C that we pass arguments by values. This is just a fancy way of saying the values have been copied to the called function. So the swap function, in this case, gets some copies of the values. Just look at the image, which I think is really good in explaining to you implicitly what is going on. You see that the main function is clearly isolated from the swap function. They can communicate only through arguments, in this case, x and y. So inside the swap function, the arguments n and n1 are just, as I said, mere copies. So as you surely know, x and y are not n and n1. They are different variables with the same values. This is the biggest concept you have to understand, frankly speaking. Okay, so now we are in the swap function scope. It means that we are inside this block. I don't see any more main. I don't see all the variables which are inside main. I don't see anything else but the swap function. Inside the swap, I have my variables n and n1, and then I do my magic. I just do my swap of the variables. So as you can see here, I use the comma operator. I will later explain what is going on, but by now it is not the point. I just want you to understand that this black box magic swap function performs a swap, but not in the variables which are in the main function. So when the swap function ends, well, I lose the access to this block of memory. It is like everything gets cleaned up. I cannot really make reference to this spot in memory. Of course I can. The values are still inside these spots. I mean, I have the variable swapped and n1 in the same location where I left, but I cannot access. I can in an Akish way, but this is not the point. Understand me. Let me explain you, practically speaking, what is a stack. You have your Tinder function that is calling another function, like in this case, the swap function. So boom, I allocate another space for this block function. Then this swap function performs its magic, and when it finishes, I deallocate this space in memory. After the swap function, indeed, I call the printf function, which is another function, gets called, boom, gets allocated exactly in the space where the swap function was. So it is gonna overwrite what was before inside this place. I suggest to you to really understand what is a stack, how it works, and for you it's gonna be super easy to understand this concept. Coming back to us, you can see here in my main function, I still have x and y, which are the same values, because I've not swapped this value. I just swapped the value which were inside the swap function. So when I print these values, I just get 42 and 24, as you saw previously with my program. Then the process ends, it's over, and the controls goes back to the operating system. Okay, this is basically the flow, the control flow of our program. Now let's watch the non-naive solution, and indeed the solution that will make you pass this exercise. This is the real swap. The main is the same, and my function this time takes 2 pointers to the variables. So this time, what do I have to do? Well, of course, I change the name of the function, and then I give not the values, but the addresses of the variables. So this time, I don't have the arguments which are passed by values, aka copied, but I have the addresses themselves. So I have my swap function that is able to reach my main function and do its magic there, not inside itself, okay? This is the big difference, of course. So my swap function gives the addresses, as I just said. And here, as you can see, in my swap function, I have this time as an argument, of course, the pointers. Here I have a pointer to a variable int that is called a, and a pointer to a variable int that is called b. Now you might say, well, why here I have an ampersand to give an address and here I have star? This is the notation of the C programming language. It is just the way it works. I recall to you that you can think about these arguments like, if I dereference this a, what is a? Well, it is a pointer. I get an integer. So I have my declaration of the 2 pointers here. Then I declare a variable which is a temporary variable. Inside the temporary variable, I put what is inside the pointer a. As you can see, the confusing part of pointers is that the declaration is equal to the referentiation. Well, this is a design issue. It is just the way it is. Maybe they could have chosen a different way to declare a pointer and to dereference a pointer, but this is just the way it is. It's not that difficult, so it is not a problem. So I say inside my temporary variable, put what is inside the pointer a. I recall to you that this is a value which is inside my main. Then I say, okay, inside my a, what do? I put what is inside b. So I just make the swap inside directly the main function. And then I put what is inside b, the value tmp, which is the value that is inside my swap function. There is a very good video from CS50, which is a channel that you must follow because it's the original gangster of computer science, I think, on YouTube, that really explains why these lines should be performed when you want to make a swap. Of course, I will link the video so you can check by yourself. But essentially what is going on, you are dealing with real physical stuff. The RAM is a physical entity. It is like swapping the liquid from two glasses. How can you do that? Well, you cannot just pour the liquid from one glass to the other glass, which is filled. You cannot, in the physical world. So what do? You take a third glass, you pour the liquid which is inside this glass, and then what do? You make the swap, okay? Then this glass is empty, and then you take the just filled third glass, temporary glass, and you fill the just emptied again glass. Okay, visually is much better, so just check the video. It is a super easy concept. You can think about the RAM bytes essentially like glasses filled with electrical states and not with the liquid. And when you empty a glass, when you empty a byte, you're not empty anything, you're just copying the values, of course. But the concept is the same. You're dealing with physical stuff. Always think about the RAM as a physical entity. Okay, let's check how this code works and if it works. As usual, I compile and then I run. As you can see this time, everything worked accordingly. And now I will show you the theory visualization of this code. As usual, we start from the previous situation. We have our main function, which contains the variables 42, 24 inside x and y. But this time we have a big difference. This time I give to the swap function the addresses of x and y. Practically speaking, what does it mean? Well, when I call my swap function, this time, this separate block has the power to manipulate stuff which is not inside its block. You see, when a swap performs its magic, its duty, it's able to go to specific addresses which are outside its scope. So the pointers at the end of the day are just a tool that allows me to manipulate data which are not inside my domain. So long story short, it is a different way of communicating between functions. These functions can communicate through copied values or through pointers. Are you getting it? So a program is just a series of functions calling one each other. These functions are separated, but they can communicate in two ways, which are normal arguments when these values are copied, or pointers. So just look at this image and really understand what is going on. When I do reference n, I am accessing the x value. When I do reference n1, I am accessing the y value. Is it that difficult when you visualize the blocks of the function, when you understand how the stack works, when you understand the flow of the process of the program? I think it's not that difficult. Always stick to visualization when we are talking about pointers. This has really helped me to sort it out, this tricky argument. So coming back to the program, the swap performs its magic, and this time look at this. When the swap function ends, its space is deallocated, so the print function will occupy the space for its purpose. But the main function this time has the values changed. So when the printf is called, I have a very different outcome as you saw before. This time I have the values which are swapped. So the process this time is over, like before, the stack is empty, control is back to our operating system. So this is the solution for your exercise. Now I want to show you something extra. So look at this. This time I've used the so-called comma operator. Yeah, indeed, the comma used in this fashion is considered an operator. So here I have the same operations, like I just give to the temporary variable what is inside A, what is inside A, what is inside B, and so forth. You already saw it. But I have done everything in one line. Let's see if it's gonna work. See, it is exactly the same, of course. It works properly. So you can use this comma operator to perform calculations which are highly related. Like in this case, these three operations, these three instructions are highly related to each other. They work together to perform a specific task, which is of course the one of swapping two variables. So the comma operator is very useful to create compact lines, highly related. I know, thanks to the comma operator, that this operation will be performed for first, this one for second, and this one for the last. Of course, the order is important, and the comma operator allows me to know this. This is suggested also by Kernighan and Ritchie, which essentially created the language. So when you have highly related operations, maybe I personally like this kind of writing, which is super compact and I simply like it. Now you know, and now you know. I think that for the school is not okay because maybe it's too much stuff to digest in one line, but you can use it. One thing more for you. Now I want to show you the pro solution that I was talking to you about. This is called the XOR swap, which is, I think, a really cool one, especially when you will become an hacker. You need to understand the bits at a core level if you want to make real damage in this world, right? So here comes the solution for you. This is the XOR swap, which is, what is that? Mamma mia, it seems really complicated. But we're going to understand very intuitively how it works. Theory, I won't touch theory because I hate theory. So I want to give you tools to use this XOR swap on a practical level, okay? So the function is the same. I just have to change here as swap naive. So the main function is the same. As always, I just do my thing, two variables, I call the swap, and then the control goes here. Let's check it out. This time, I just make this operation. You see, I bypass the temporary variable thanks to this bitwise trick. I don't know if you are aware of, but C allows you to manipulate single bits. This is indeed a very powerful language, and this is one aspect of it. You can really go inside the single bits and turn on and off. This is called an XOR operation. You see, there's a little sign, allows you to perform bitwise. It simply means bit by bit operation. I won't explain to you what is an XOR bit by bit because, of course, again, there is plenty of resources. I will leave you. I leave you a link. Maybe just check it out and come back. But it is plain vanilla easy. It's super easy. So I do this operation, which is, please give me the value which is at A and the value which is at B, and make a bitwise XOR of these two values, right? I want you to see the two values as two locks, two normal locks. When I perform the bitwise XOR, I just go to lock these two values. So I have a new gibberish random value that encodes, that hides, if you want, the information coming from A and B. So I just take these two locks, I lock them together, and I have a value, a gibberish value that I stock inside my A position. Now check it out. If I perform an XOR with the value which is in B into my gibberish value A, which is the double lock element, my random value, what is going to happen? Well, I get the value A back. You see? It is like in this operation, I insert the key into the lock of my gibberish value and I remove the B lock. So I remain with the A lock. I don't know if you see this. It's kind of easy if you just look to the locks images. Now I can do the same to get my B back. So I take my gibberish value, I take my double lock element, and I plug in the value A, which in our case is the value B, because of the previous instruction. Then what do I get? I get the value B that I stock in my value A. So the XOR operator gives me this toggle encryption power, if you want. I want you to think about that. I have two values. I XOR them together, so I create a double lock that encodes in a random gibberish value information coming from both the elements. Given this gibberish value, given this double lock, if I plug inside it the value A, I get B. If I plug B, I get A. Okay, it is kind of removing the information. If I plug B, I remove the lock B and I stay with the value A. And the opposite is true. So this is a fancy swap that doesn't require the temporary value. This is called the XOR swap, and this is cool. So if you want to understand it on a theory level, you need to understand for yourself how it works. Just check all the bits, check why it works exactly like I showed you before. If you are a practitioner, if you are a thinker, if you really don't care about the theory part, I think that the visualization I showed you, it's really intuitive, really easy, and allows you to use this trick when you want. And yeah, that's it. Let's check it out if it works. Compile and run. Well, you see, it works. The hacker way to make a swap. Okay, that's it for this WAP program. I hope everything is clear. Of course, the take-home principles here are understand the stack, how it works. When you call functions, what is going to happen inside the stack, and how, thanks to pointers, functions are able to manipulate stuff which is not inside their personal space, their personal scope. That's basically it. Good luck for your work and see you next time, maybe. Okay?